Good morning, friends. This is a series of UV visible spectroscopy lectures. In the last lecture, we have learned about the filter which acts as a wavelength selector. Now, the prism and diffraction grating, these are both are employed as a filter in UV, any type of photometer like colorimeter and spectrophotometer. Now, we will focus on this topic in this lecture. We will focus on this topic, that is light source. Now, what is the light source that are employed in the UV visible spectrophotometer, or you can say colorimeter? Now, generally in colorimeter, tungsten filament lamp is mostly used as a light source which emits the light of particular wavelength that can be utilized in the measurement system. Now, in the UV visible spectrophotometer, generally two types of the lamps or two types of the light source, radiation source are used. First is tungsten filament lamp. Now, tungsten filament lamp is the most common ordinary lamp utilized in any type of photometer. Now, the second one is discharge lamps. Now, the discharge lamps are hydrogen discharge lamps, deuterium, that is D, deuterium discharge lamps, and xenon discharge lamps are employed as a discharge lamps in as a radiation source in any type of spectrophotometer. Now, we will focus in this lecture tungsten filament lamp. Now, tungsten filament lamp is nothing but it is an ordinary light bulb or white bulb that should be used. It is similar to white bulb employed in our household systems. Now, tungsten filament lamp is useful in the visible region of UV visible spectrophotometer. UV visible spectrophotometer has a visible region, and that visible region is nothing but it is generally started from 380 to 800 nanometer scale. In that particular region, tungsten filament lamp is used. Now, it is similar to ordinary bulb used in our houses. It consists of a piece of tungsten filament which is heated in a controlled atmosphere. Now, tungsten filament lamp has obviously tungsten filament will be used as a for a heating purpose in a controlled atmosphere. Continuous power supply is needful to avoid fluctuations in reading. Now, we should employ continuous power supply because it encounters in reading. So, to avoid the fluctuation in reading, we use a continuous power supply. Now, tungsten filament lamp emits the radiation of wavelength ranging from 320 nanometer to 2500 nanometer. So, this is the broad region of visible as well as IR region, because above 800 to 25 nanometer to 500 nanometer, it should be this point should be remembered, because 320 nanometer to 800 nanometer, this is the range of visible light. But tungsten filament lamp emits the wavelength in a particular IR region also, because 800 nanometer to 2500 nanometer, 2500 nanometer. So, this is a broad range of IR region. So, maximum radiations emitted by the tungsten filament lamp lies in the region of IR spectra. The intensity emitted by lamp depends on the applied voltage, that means final temperature of the filament. So, temperature of the filament plays an important role because it emits the radiation, and that whatever the intensity, that is directly proportional to applied voltage, and that is directly proportional to temperature of the filament. Now, as is can say, I have already said that maximum radiation of tungsten filament lamp are generally found in IR region. The lamp emits the 90% in the IR region. So, IR region is can say tungsten filament lamp has one drawback, that maximum 90% radiations are come out in the IR region. through the tungsten filament lamp. 15%, only 15% radiation emitted by tungsten filament lamp found in visible region at 2500 degrees centigrade. So if the lamp is heated to a particular temperature, that is 2500 degrees centigrade, then we get 15% radiation in the visible region. Now if the lamp is heated to 1725 degrees centigrade or approximately 1700 degrees centigrade, then 1%, only 1% radiations are emitted in the visible region through a tungsten filament lamp. So this is the most drawback of the tungsten filament lamp. Advantage here, advantage, the lamp is readily available. So ordinary lamp is also available. So in that we get the tungsten filament lamp. Similarly, tungsten filament lamp for a UV spectrophotometer is also readily available, and it is cheap. The cost is very low. They are not we can say as inexpensive as a discharge lamps. So this is a typical block diagram of a tungsten filament lamp. Now this is the red region, or we can say the red part of the this bulb is nothing but this light source is nothing but the tungsten filament. So these are the basic components of the any type of light source uses, and these are the radiations. These arrow indicates the radiations come out from the tungsten filament lamp. So this is the base of tungsten filament lamp. So this is the block diagram of tungsten filament lamp. So this is all about the, you can say, tungsten filament lamp. In the next lecture we will see the discharge lamps. So this is the one type of light source, that is a tungsten filament lamp used in UV visible spectrophotometer. Especially it is utilized in visible region. So how the voltage, in which way how voltage is kept constant. What is the principle of, what is the construction of tungsten filament lamp? What are the drawbacks of tungsten filament lamp? They are associated with the infrared region. And what are the advantage of tungsten filament lamp? This video deals with this part. So with this content I conclude this lecture. We will again meet with the same content similar to this video one, that is nothing but the discharge lamps, hydrogen, deuterium and xenon discharge lamps. Thank you very much for patience listening.